Alright, the second pink sheet review is simplifying square roots. Now, we're going to use a rule. A rule says that if you have any number inside of a radical, inside of a square root, we can change it to the square root of a times the square root of b. Now, what we want to do is we want to change it to the square root of a perfect square times the square root of b, where b has no perfect square factors. And so we need to know our perfect squares. We need to know that 1 squared is equal to 1, 2 squared is equal to 4, 3 squared is equal to 9, 4 squared is equal to 16, 5 squared is equal to 25, 6 squared is equal to 36, 7 squared is equal to 49, 8 squared is equal to 64. We need to know 9 squared is equal to 81, 10 squared is equal to 100, 11 squared is equal to 121, 12 squared, 144, 13 squared, 169, 14 squared is 196, 15 squared is 225, and then you can kind of go from there. Now, the idea is this. Say you had the square root of 24. I want to break this down into 2 square roots. And I say, alright, 24, in my head, that's 1 times 24, 2 times 12, no perfect squares. 3 times 8, no perfect squares. 4 times 6, hey, there's a perfect square. Is there any perfect squares in here? No, I don't think so. That's 2 times 3. So it's 4 times 6. This is my perfect square. That's 2, because the square root of 4 is equal to 2, times the square root of 6. So the square root of 24 is equal to 2 times the square root of 6. So the idea is, alright, find that perfect square factor. Now another one, let's go square root of 48. Now you take the number 48, and you think to yourself, alright, well, this is 1 times 48. This is 2 times 24. This is 3 times 16. Ooh, I like that, because 16 is a perfect square. So, the square root of 16 times the square root of 3, so this is 4 times the square root of 3. So you can check this out and deal with whatever you need to deal with. The square root of 99. This would be the square root of 9 times the square root of 11. So that's 3 times the square root of 11. So you always want to make the perfect square. There's your perfect square. There's your perfect square. There's your perfect square. All of those are perfect squares. And you can just, you have to know what these are in order to make your perfect squares. So, if we go to our master sheet here, we think about perfect squares. One squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared is 16, 5 squared is equal to 25, 6 squared is equal to 36, 7 squared is equal to 49, 8 squared is equal to 64, 9 squared is equal to 81, 10 squared is equal to 100, 11 squared 121, 12 squared 144, 13 squared 169, 14 squared is 196, 15 squared is 225, and so you got your perfect squares right here. Now simplifying a square root, you're going to take the square root of a number, and it's going to be equal to the square root of a perfect square times the square root of a number, where the perfect square times the number is equal to that number in there, that radicand in there, and then it equals a number times the square root of whatever number's left over after that. And if you don't like that, you could just say that the square root of AB is equal to the square root of A times the square root of B, where A is your perfect square. Right there. So you have that going. So there's ps2, your pink sheet. And so now I have Pythagorean theorem. I talked about Pythagorean triples, where 3 squared plus 4 squared equals 5 squared, 5 squared plus 12 squared equals 13 squared. There's all your perfect squares. Simplifying square roots. And we're well on our way to filling this guy up.